this question says find the y ds at s equals to 1, y equals to 1 if s cubed y cubed plus s equals to y. This particular question, to solve it, we'll follow our normal steps. And it's an implicit derivative because we have both s and y in the equation, and you can see that we have two y's. One is standing alone, whereas one is not standing alone. So we need to solve this by implicit method because the y's cannot be combined to be one thing. This is cube and this is just unity. So we use implicit differentiation method to solve it. And earlier on in my previous video, I've shown you how to solve this thing without going through the normal way, because the normal way is always confusing for students. So I gave a formula that you can use to solve it to make it easier for you. So step 1, as I already mentioned, this is an implicit differentiation. So the next thing is that we write down the formula under implicit differentiation, which says that the y dx is equals to derivative of that function you are given, of the function itself, that's of this f of x, keeping y constant, then derivative of y keeping s constant. That means here we have minus. So in step 2, we need to get the function f that we are going to use. We need to rearrange this equation in step 2. So step 2 says if you do this thing now, it will not work. Step 2 says rearrange the equation given. So we rearrange the equation given, and it is given there as this, as s cubed y cubed plus x equals to y. So we're going to take this y to meet this. We now have s cubed y cubed plus x equals to, minus y equals to 0. That's when this comes over. So this becomes our function f of s comma y. So f of s comma y, that means it has both s and y inside the function, is equals to s cubed y cubed plus x minus y. So it's this function that we will differentiate the first time with respect to x, keeping y constant. So we'll come to this one, we differentiate y with respect to y, keeping s constant. So step 3, that's the next thing now. Step 3, find f prime of x and f prime of y, and this implies that our f prime of x is equals to, that's from here now, from this equation now, differentiate this. If you differentiate s cubed, that means bring 3 to the front, 3x, remove 1 from 3, you have 2. S and y is like constant there, it will just be what it is, no change. If you differentiate x now, it will give you 1 plus 1 minus y is a constant. So if you differentiate a constant, it will give you 0. There's nothing attached to it, so it's just a constant. In this case now, it was different because they're multiplying each other. So you work with this. You get just like saying that this is 2s cubed, and you differentiate s cubed, leaving the 2 as a constant. But in this case now, it's standing alone as a constant, y. So it will just become 0 automatically. So I will just say minus 0. So we have minus, so we have minus 0. And this is equals to 3x squared y cubed plus 1. So moving on, our f prime of y equals something I would do it here. I will now keep s, like here now, I will keep s constant and work with y. So this will be 3y squared, then s cubed, times I'm bringing 3 to the front of y, then removing 1 from that 3. Then plus, now s is a constant, it will be 0, minus y, it will be 1, because if you differentiate y closer to, that's why closer to y to give you 1. Yeah. So that's how we arrive there. So we have 1 here. Okay, next, this is 3. Next, we put the y, however of y in simplest form, which is equals to 3y squared s cubed minus 1. After solving them. So we now put both of them inside this formula. Our dy ds equals to minus bracket, what's our f prime of x? See it here. 3x squared y cubed plus 1 all over f prime of y, that's this one. This one here now. That's 3y squared x cubed plus or minus 1. And then if you open the brackets, you can leave it this way, it's still okay. Or you can try to open the brackets, minus this and minus this. That's the same thing. This is equals to minus 3x square y cubed plus, minus 1 all over 3y square s cubed minus 1. So we're not done yet, we want to find this. So at s equals to 1, the first one, 1, and y equals to 1, our dy dx is equals to, that's from here now, minus 3 brackets, x is 1 square, then y is also 1 cube minus 1 all over 3 brackets, 1 square, 1 cube minus 1, and this is equals to minus 3 times 1. This is 1 square is 1, so you have minus 3 times 1, 1 cube is 1 minus 1, 3 times 1 square is 1, 1 cube is 1, then we have this should be okay, that's correct. So we have minus 1 here, and this equals to minus 3. That's 3 times 1 is 3, times 1 is also 3, then minus 1 all over 3 times 1 is 3, times 1 is also 3, then minus 1. Minus 3 minus 1 is minus 4 over 2, and this equals to minus 2. So that's the final answer. So dy dx is equals to minus 2.